Good day, my fellow API practitioners. My name is Olga Podolyako. I'm originally from Russia, moved to Detroit suburbs in Michigan almost 30 years ago. Today, my talk will be about API governance in the age of AI. I worked as a developer, enterprise, and integration architect for a long time before I moved to Microsoft. Now at Microsoft, I work as a principal API architect for the Microsoft Graph platform. I oversee the Microsoft Graph API governance and standards. API governance faces a big challenge today to balance the need for speed and innovation in API products with the assurance that their API products are of a quality and they are secure. Recently, we learned that AI technologies such as Copilot can increase the productivity of knowledge workers, which includes software engineers and architects. And this increase can go up to 29% based on the industry's experience that use them. The purpose of today's talk is to explore how AI technology can help with API governance. I started my exploration of technology by asking an AI agent to write a story about how AI can help. And it created a story that illustrates importance of AI-driven API governance. So the story goes like, there were two rival tech companies, Innovasoft and Classitech. Both companies offered a range of interconnected products, and the APIs were crucial for enabling communication between these products. Innovasoft embraced AI-driven API governance, implementing it across the entire product range. AI enforced guidelines, managed permissions, and ensured optimal performance. Classitech, on the other hand, relied on a manual API governance. And a team of reviewers checked every API for compliance, verified API constraints, looked over access policies. One day, both companies released new product features simultaneously. Innovasoft AI-governed APIs ensured seamless integration and a smooth user experience, while Classitech, which relied on manual governance, released a buggy API. Customers complained. Classitech brand reputation took a hit and their sales suffered. Innovasoft, on the other hand, received glowing reviews and they eventually became a leader in the tech industry. Every story contains some element of truth. So let me tell you how much truth we discovered from our journey. Let me just start with describing the scale of the API platform. Microsoft Graph Platform provides access to cloud data and services across Microsoft SaaS products, including Office, Teams, Outlook, Entra, and many others. Microsoft Graph has common authentication model, semantic consistency, and provides common developer tooling. Graph data model is centered around the user. User has multiple artifacts such as email, tasks, files, contacts, all interconnected in one system. To support the common data model, Microsoft Graph has more than 12,000 unique resource types and more than 2,000 relationships between them. When we work at Microsoft, we have more than 100 different product teams delivering their APIs to Microsoft Graph platform and supporting this data model. We have 3 API review boards doing review manually. And we have also a single authority body, Graph API Council, which overseeing standards and process decisions across multiple organizations. We process more than 2,500 of API reviews per year. And every day we have new changes for APIs or new APIs delivered to the platform. So we truly rely on API governance automation. And this automation goes across the entire life cycle of API. We start with planning and we continue supporting our APIs in production. We rely on Azure DevOps as our work management system. We also all formal linting rules are implemented and verified automatically. We also have additional formalized rules for permissions, for example, or for security controls, or for documentation generation. These rules are implemented across the life cycle and automated. Security is verified almost on every step of the life cycle for different purposes, starting with machine-readable permission description, looking at the testing of the permissions, and also monitoring in production. The single manual activity in this process is API review. API review is also a single quality gate to the production environment. So, can we fully replace manual API review with an AI agent or with AI technology? This is a topic we will discuss today, and we will start with exploration, what we actually do during the API review. Historically, API review was focused only on API design. But as we embraced API as a product approach, we extended the review to ensure that API developers address other API concerns such as security and performance. So during API review, API reviewers usually advise on evolvable API first design so that API design would fit for specific product scenarios for new and existing services. We ensure that new changes don't break client code. We also verify API design compliance with graph guidelines and ensure completeness of API description, such as making sure that we have CRUD capabilities or query parameters for easy consumption by human and AI agents. We guide API producers on API quality, including permission design, design for performance, and traceability. We also make sure that new API proposals are aligned across Microsoft Graph surface because we have a common model. What we observed recently is that almost 25% of our time, of API reviewers' time, is spent on educating engineers one-on-one about API review, about API design best practices, about graph requirements, gateway features, how to correctly utilize gateway features, or about process instructions, how to start onboarding, how to start a review, how to schedule a review meeting. We realized that it's very inefficient to do one-on-one consultation for every team. And it also leads to significant frustration if we explain design guidelines later in the cycle. So 3 years ago, we decided to create a short and concise graph design guidelines. We created these guidelines, and we also provided a library of patterns. A pattern is a bite-sized document which provides solution to well-known problems and provides a lot of examples for reuse. But after 2 years, we observed that developers don't use this very much. And we still continue to educate them during API reviews. And then we started thinking, why does it happen? And we realized that actually it's not a problem with lack of information. It's a problem with the overload of information. Microsoft Graph has tremendous amount of documentation. We have design guidelines and patterns. We have internal and external specifications which developers need to know. We have production and gateway specific onboarding processes. We also have a very rich technology information described in internal wiki and also in the Stack Overflow. So after we realized that it's an overload of information, we decided that to speed up the API governance process and reduce review time, we need to help API developers to find the right information quickly so that they can use it in their flow of work. And we thought that AI technology can enable developers to ask this simple question in natural language and get answers based on our comprehensive documentation. So our team started experiment with a new technology, AI-based technology, we often call semantic search and or RAG functionality. Using semantic search results to ground an LLM response for a chatbot to produce simple answers is called retrieval augmented generation pattern, or RAG for short. This architecture pattern relies on the vector search capability of machine learning models to create the vector representation of source inputs, which can be text, image, or other content, and then we create a vector index of it. When searchable content is represented as vectors, a query from a user can find similar matches in related content. And embeddings is just another type of vector representation that encodes the semantic meaning of the content, such as the documents, images, or other mediums. Our API teams usually start their journey in the governance portal. Governance portal is where they create work management artifacts and submit their API review artifacts as well. So we thought that governance portal is an ideal single place where we can provide this search support for our internal teams. Obviously, for our experiment with RAG pattern, we used Azure AI building blocks, such as Azure AI Search, Azure OpenAI models, blob storage, and semantic kernel orchestrator. To enable semantic search, we need to solve two problems. The first problem is process all documents in our knowledge base and create an index of them. And the second problem, enable search interface. So for document processing and indexing, we used lightweight text embedding model called ADA002. After we create an index, we enabled search experience. Search experience we enabled using semantic kernel and conversational LM. Semantic kernel orchestrates the query from the user, submits it for factorization, search using AI search response to the query, combines the search results with conversational context, and submits to the conversational LM to produce a final answer to the user. Our experiment proved that the RAG solution can provide a high relevancy and accuracy answers for simple questions, such as how long does API onboarding on Graph take, or what is considered a breaking change for Graph APIs. And in some cases, we achieved relevance almost 100%. So what can we tell you in conclusion about our experiment? Based on our experience, a good semantic search can significantly reduce time for API review by almost 20% and therefore speed up API governance. We also can leverage the ability of AI models to generate content based on templates and natural language descriptions and help API developers create drafts of their API designs. This can reduce the load on API reviewers even further and decrease manual API governance activities. What we also learned that AI models have proved to be very flexible, but making them consistent and reliable and produce high-quality review artifacts requires a significant engineering effort so far. Based on our learnings, especially from the GitHub Copilot, for example, there is a great potential for AI to help API developers and API reviewers in the same way as in other programming domains. However, we still believe that the human API reviewers should be in the loop to solve complex problems which are not yet reflected in the knowledge base, and that problems that require a broad expert perspective and background. We know more that we can tell. From our experience, we can automate most of API governance and shorten API review time by more than 40%. Therefore, the story about fully automating API governance has a lot of truth in it, but it's not yet a reality. Thank you very much for your attention and listening.